Good morning, sir. My name is Ko Xiao and I'm from Group 9. So I'm gonna to having a presentation about our project with the title of Smart Temperature Monitor System based on the face recognition system. So our concept will be like building a smart camera in a room. Then the smart camera will capture the pupil's face in the room, then send to the cloud computing service. Then it will count the people inside it and monitor the electricity according to the people. Then for the comparison of relevant cloud technology will be the GCP, AWS, and Azure. So before going about it, so I was talking about the three model, which is IaaS, PaaS, and SaaS. So IaaS basically like you pay and you go. So the famous one will be the Alibaba Cloud and Amazon EC2. Then the PaaS will be like giving a business tools and hardware on the internet. Then people can using them or having using them to make complex things like Heroku. Then for the SaaS, it will like online software did not require to download or installation. So the famous one will be the GitHub. So in this project, I'm only using the two things to compare it. It will first one will be the storage, and the second one will be the processor and virtual server. Then about the literature review, they have in the research we're going to use the 5 to 4 research. Then I will talk about 3 and the 2 more will be about for my partner. So basically the 3 things will be the Amazon Alexa virtual assistant. Then then second one will be the Samsung SmartThing and application. Then the third one will be a library automation system, Mandarin M5. And that's
Now I would like to present about the problem statement. The first problem we face is how we are going to track the people and how to calculate it. Our solution is we use a smart camera to detect and calculate the people. The second problem is the cost will be expensive or not. The cost is just sent to CCTV only, so the smart camera is not expensive. The third problem is what temperature should be used in less people or more people. We use smart camera to calculate how many people inside, then we control the temperature. For example, if 20 to 30 people inside, we set it at 23 degrees Celsius. And the literature review I find is IoT based temperature and humidity controlling using Arduino and Raspberry Pi. Arduino control system is a system designed to help users to measuring the temperature, wetness, pressure in place or anaesthesia area, and the head measurement of the device. And one more literature review is monitoring food storage, humidity, and temperature data using IoT. It is using IoT to control the temperature for food storage. And for the future work, we allocated the technical report. The technical report includes background study, problem statement, literature review, and future work. Dasan will be responsible for the background study and problem statement. Sihao will be responsible for the literature review and comparison of relevant cloud technology, which is Google Cloud, AWS, and Azure. And me will be the responsible for the literature review and future work. And the full manner report, we try to fix it at ourselves, we all together.
Hello, sir. My name is Darshan and I'm from Group 9 and I'll be talking about the solution architecture diagram for our group. So, before I start, I just want to tell the overview of our system is that we wanted to create a system whereby the system will take images of an area. We set up this smart camera around an area and it will keep on take images of that area to detect how many people inside that area. For example, we set it up in a library. We put a few of this camera around the area we want to keep track of how many people are there at that place. So we use the recognition service to detect how many people are there at that place, and then we will modify the temperature of that area by checking how many people is inside that area. If no people at all, then we actually off the aircon in that area. So that's how the system will work in overview. So we connect the smart camera that we want to use to take the pictures, right, into the IoT core. We need to do this so that we can use all the AWS services AWS services. So once we have set the smart camera into the IoT core, then we can use all the services, right? Then we want to use one service called SNS, Amazon SNS, to keep in track if anybody trying to breach our data or not. So anybody trying to intrude and see whatever thing that we are storing, right? So this Amazon SNS will send message to the owner, the person who handled that particular system, saying that somebody trying to check out the data. So this is for security purposes. Then we have this Amazon Kinesis data stream, Amazon Kinesis Firehose, and then Amazon S3. So basically, when we connected the smart camera, right, we wanna check how many people are currently like based on for a whole day. We wanna keep the analytics in check, right? So we can do those analytics by having this chain of services. Basically, the Amazon Kinesis data stream, we send the data through the Amazon Kinesis data stream into the Amazon Kinesis Firehose. So this Amazon Kinesis Firehose will then process the data and then store it into the Amazon S3 bucket. So this is just what we wanted to do. So we want to keep the processed data in the Amazon S3 bucket so that when after we create a Lambda function to transfer the data that we stored inside the Amazon S3 into the Amazon recognition. We need to do this so that the Amazon recognition, because we know only the Amazon recognition have the service to detect the people inside the images, and the thing is called detect faces. So we use the Amazon recognition service, the detect face service, and we recognize the image. Oh, now no people at all, or now a lot of people in that area. So we set the temperature based on how many people are in that area currently. If no people, then we set the temperature to, basically we off the aircon or light or whatever. But the main thing is the temperature control system, so we don't talk about the light, we only focus for the temperature part. So basically the aircon. And then we have this Amazon Dynamo DB. So this Amazon Dynamo DB, we wanted to use Amazon time stream. Wait, AWS time stream or Amazon time stream? I think it's Amazon time stream, but we decided to use Amazon Dynamo DB because we couldn't find the time stream service inside the AWS, and it's not free. The Amazon Dynamo DB was free, so we decided to use this to store the data, anything that the smart camera captures into the database. It's basically as a database, right? So we store the things inside here.